This is question number 48. Paper 1, TS6. Now in this question we are supposed to find the limiting value of the expression. So first of all we will find right hand limit and then left hand limit, and if the two limits are equal, two limiting values from left and right are equal, then limit exists. Now to find right hand limit, we apply right hand limit formula to get this. Now fractional part of h is a infinitely small number, so fractional part of h, you can see we can replace it by h. I have shown here also. Fractional part of h we can write as h minus greatest integer h, and as h is infinitely small positive number, greatest integer of h is 0, so we are left with only h. So we can everywhere we can replace fractional part of h by h, right? And now you can see the type of limit is base approaching 1 and power approaching infinity. Base approaching 1 and power approaching infinity. So what we can do, we can apply this formula 1 plus t to the power 1 by t, limit t approaches 0 equals to e. For that we need to add 1 and subtract 1, right? And now this is t, so we make 1 by t in the numerator, in the power, we multiply with t and divide with t. Suppose this is t, so we multiply with t and divide with t, and now this thing 1 plus t to the power 1 by t will become e, right? So finally we'll have e to the power t by h, e to the power t, you can see this is t by h. Now we need to further simplify this, and you can see here base is changing as well as power is changing, so we write this in exponential form. This is also e, we write this in exponential form. You can also apply L'Hospital's rule here, but that will again take time, so we follow a formula method, we prefer formula method. So we write this in, we use this formula, fx can be written as fx can be written as e to the power ln fx, right? E to the power ln fx. So we write e to the power ln of this, ln of fx, 1 by h will come out, 1 by h is in power, so 1 by h will come out. Now we take e common and cancel out, right? From this you can see we apply formula, we take e common and cancel out, and after that you can see we'll apply this formula e to the power t minus 1 by t, limit t approaches 0 is 1, we use this limiting value. So this is the part that is approaching to 0. As h approaches 0, this part approaches 0. So e to the power t minus 1 will divide with t and multiply with t. If this is t, we'll multiply this with this term and divide with this term, so this whole expression will become 1. We cancel e with e, this part becomes 1, and in the next step we have t by h, where t is this value, t by h, right? Now after this we can apply expansion approach, we can use expansion of infinite expansion of 1 plus h. You write infinite expansion of 1 plus h, we cancel h with h, and after that you can see cancel h with h, h with minus h, and cancel h square with h square, so limiting value is minus half. Now if you see left hand limit at x equal to 0, we apply left hand limit formula, 1 plus fractional part of minus h to the power 1 by fractional part of minus h goes on. Now see here, fractional part of minus h is minus h minus greatest integer of minus h equals to greatest integer of minus h is like minus 1, so minus minus becomes plus sign. So fractional part of minus h is 1 minus h, right? We replace 1 minus h everywhere. Now after we replace 1 minus h here, you can see this is no more a indeterminate form. As limit h approaches 0, this part approaches to 2, this part approaches to 1, and this part approaches to again 1. Finally the limiting value is 2 by e. So left hand limit is 2 by e, right hand limit is minus half, so limit does not exist, as left hand limit not equal to right hand limit.